Scientific notation is pretty great. It allows for people to abbreviate a number that has a lot of digits in it. So we just need to understand how to read scientific notation, how it works. These four numbers you see are all in scientific notation. We are going to go ahead and rewrite these into standard form, just into a regular looking number. Scientific notation will have some number up front, 4.97. If you notice where the decimal is on all of these, you always have a digit, so you have the 4, and then the decimal goes after it. And the next one, 5, and then your decimal. Down here, 9.798, so you have a number and then the decimal. And then it's always being multiplied by 10 to some power. So, how do we rewrite this in standard form? Well, you take your 4.97, and what we're going to do is we're just going to move the decimal. This is kind of a shortcut. We're going to multiply this times 10 to the 4th power. 10 to the 4th power basically is just multiplying by a bunch of tens, which makes our number bigger. So if your exponent is positive, that means that the number is bigger. So we're going to take this 4.97 and we have to make this number bigger by moving the decimal. If we move the decimal to the right, now I have a 49.7. Now I have 497. You can see that as you move a decimal to the right, your number gets bigger. I'm going to move it to the right 4 times because 4 was the exponent. So 1, 2, 3, 4. Here's where it's going to end up, and you fill in with zeros. So our final answer is 49700, 49,700. That is the standard form. Alright, here we have a 5.1 times 10 to the negative 5th. Now when your exponent is negative, that means that your number gets smaller. So we need to move our decimal so that this number gets smaller. To make a number smaller, you move the decimal to the left. Now I'm going to move it to the left this many times, 5 times. So here's 1, 2, 3, 4, 5. Here's where the decimal ends up, and we want to fill in with zeros. So I have a 0 here, 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 and here. So our final answer has point, and it looked like I wrote in 4 zeros, and then 5, 1. That's a really small number. So scientific notation that uses a negative exponent will give you a really small number. Alright. So now we're looking at 9.798 times 10 to the negative 1. So if you notice, that exponent tells us so much. It tells us if we should make our number bigger or smaller, and which way to move the decimal. So because that's negative, we want a smaller number. We get a smaller number by moving the decimal to the left. And because it's a negative 1, we're going to move it to the left just 1 spot. So our final answer is 0.9798. That is a smaller number than 9.798. And our last one, 3.4 times 10 to the 2nd power. Look at your exponent. It's positive, so we need to make our number bigger. So 3.4. To make this bigger, we're going to move the decimal to the right once, twice. And we're going to move it twice because that exponent was a 2. Fill in with a 0. So our final answer is 340. And that's how we go from scientific notation into standard form.